When we evaluate the indefinite integral, looking at the integrand, notice how we have the square root of 25 minus x squared, and because this fits the form of the square root of a squared minus x squared, we can determine the antiderivative using trig substitution and let x equal a sine theta, or in our case, since a squared equals 25, x equals 5 sine theta. So we will be using trig substitution to find the antiderivative. In another video, though, I'll show how we can use basic U substitution to determine the antiderivative as well. So here we'll let x equal 5 sine theta, and therefore differential x is equal to 5 cosine theta d theta. Now let's model angle theta using this right triangle here, where this is angle theta. Notice how if x equals 5 sine theta, then sine theta would be equal to x divided by 5. So the opposite side would be x, the hypotenuse would be 5, and this leg here would be equal to the square root of 5 squared minus x squared, or 25 minus x squared. And now let's perform substitution and write the integral in terms of theta. So we'd have the integral of x cubed would be 5 sine theta to the third. And then the square root of 25 minus x squared should simplify to a cosine theta, in our case 5 cosine theta. Let's go ahead and show that. We'd have the square root of 25 minus x squared, which would be 25 sine squared theta. So if we factor the 25 out, we'd have 25 times the quantity 1 minus sine squared theta, which equals cosine squared theta, which does equal 5 cosine theta. So we have a factor of 5 cosine theta, and then differential x equals 5 cosine theta d theta. Let's factor out the coefficient. Here we have 5 cubed, that's 125, times 5 times 5, which would be 3,125, times the integral of, we'd have sine cubed theta times cosine squared theta d theta. When we have an odd number of sines and an even number of cosines, we want to save one factor of sine and convert the remaining sines to cosines. So let's go ahead and do that. We'd have 3,125 times the integral of one factor of sine theta. We still have sine squared theta, which will convert to 1 minus cosine squared theta. We still have cosine squared theta here. Now the reason this helps is if we let u equal cosine theta, then differential u would be negative sine theta d theta. So let's perform that substitution on the next slide. So again, if we let u equal cosine theta, then differential u is equal to negative sine theta d theta. So we could say that negative differential u equals sine theta d theta. So now I'll write this in terms of u. So we'll have 3,125 times the integral of, again, sine theta d theta is equal to negative differential u. Let's factor out the negative. Here's our differential u. And then 1 minus cosine squared theta would be 1 minus u squared. And cosine squared theta would be u squared. Let's go ahead and distribute. So we'd have u to the second minus u to the fourth. And now we'll find the antiderivative with respect to u. So we'd have u to the third divided by 3 minus u to the fifth divided by 5 plus c. Now let's go ahead and write this back in terms of theta. Once we have it in terms of theta, we'll write it back in terms of x. So here we have negative 3,125 times, this would be 1/3. Remember, u is equal to cosine theta, so we'd have cosine cubed theta. and then minus 1/5 cosine to the 5th theta plus c. Now we'll go back and use our right triangle to determine cosine theta. Remember, cosine theta would be equal to the ratio of the adjacent side to the hypotenuse. So cosine theta equals the square root of 25 minus x squared divided by 5. So this would give us negative 3,125 times 1/3, and then we have the square root of 25 minus x squared divided by 5 raised to the 3rd minus 1/5 times the square root of 25 minus x squared divided by 5 to the 5th. Now we need to simplify this. Remember that 3,125 is equal to 5 to the 5th. So when we distribute negative 3,125 here, notice here we have 5 to the 3rd in the denominator, and this would be negative 5 to the 5th in the numerator. So this ends up being negative 25 thirds times, now the square root can be written to the 1/2 power, so we would have 25 minus x squared, and the exponent would be 1/2 times 3, or 3/2. And now for the second product here, notice how we have 5 to the 5th in the denominator, so that's going to simplify with 3,125, but we still have one factor of 5 here in the denominator, and we would have a negative times a negative, so it's going to be plus 1/5, and this is going to be the quantity 25 minus x squared. The exponent would be 1/2 times 5, or 5/2, and then plus c. So this would be our antiderivative. I hope you found this helpful.